to our sponsors. They make this possible, and yeah, they make it great. Anyway, so today we got 2 talks lined up for you, 2 great talks that I'm excited about. The first one is by Jesse Bahr, and he's going to be speaking to us about arrays, tips, and tricks. We're going to be talking about forEach, map, filter, reduce, all sorts of really good stuff that's like my bread and butter with what I do, like all the time. And then the second, we're going to have my friend Kent C Dodds. He's going to be speaking to us a beginner's guide to ASTs, or in other words, abstract syntax trees, and he'll tell you all about that, but I will tell you that they are really cool and really powerful, and I'm really excited to hear what he has to say. So, looking forward to both those talks. Before we dive in, a few points of housekeeping. If you guys remember, last time we announced, hey, we're on Slack, and we've had a handful of you guys join. We'd love if even more of you guys would join, and we can have some discussions about Angular, Angular 1X, Angular 2, or just other things relating. Please come join us. We do have a Google form that you go through. If you follow that link, it will have you accept our code of conduct before you get an invite to Slack. And then we'll send you an invite and you can join us. And also on Slack, we have a volunteers channel. In advance of this meetup, I posted some things that anybody who wanted to could volunteer for and help out. And so if you want to get more involved, that's a great way to do it. So just join that channel and look out for opportunities as they arise. Also, again, we're community driven. You know, we run off volunteers. We also are community driven with our talks and our submissions. We had both of our talks. They were submitted through our GitHub. And we just use the issues to track them, and we put labels on them, and it's great. We love it. So if you have an idea for something to speak about, that you want to speak about, submit it on GitHub. If you have an idea for something you want to hear somebody else speak about, put it on GitHub. If you want to speak but you don't know what to speak about, go check GitHub and see what other people have submitted. We have a lot of them that are looking for speakers. So there's lots of great topics out there already. So please get involved. And you know, this is kind of how we operate. You know. Okay. Again, going over, we do have a code of conduct. I encourage you to review it. That is also on our GitHub. While we will have you explicitly agree to accept it to get onto Slack, it is something that does apply even for attendees here. So I encourage you to get familiar with it. In 2 words, it is be nice. But there's actually more than 2 words in it. Okay. And with that, I think we'll start and we'll turn it over to Jesse and we'll just dive right in. Okay, Jesse.
Oh, thanks. Okay. Can anyone hear me? Maybe. Check. Test check. Text. Ooh. All right, come on. Can you guys hear me? I don't think the microphone's working. Is it? Okay. Okay, be loud. Got it. All right, where'd everything go? Great. Thank you. All right. Hi, everybody. So I'm going to talk to you about the JavaScript array a little bit. First off, let me introduce myself. I'm Jesse Bahr. I work here at Adobe. I'm an engineer consultant. So I help Adobe's customers use Adobe's stuff better, which is awesome. I get to work on a lot of different cool stuff. let's see, I like video games, playing Rocket League and Overwatch right now. Have 2 kids. I'm from New Jersey. Been here for about 13 years. I think that's it. So the code that we write can be amazing, and I'm sure you guys have had this experience, but I love it when I get a really hard problem. The data is coming in all out of whack, and I can fix it, and I can fix it in a way that's concise and it's beautiful. You can look at the code and know exactly what it's doing, but it's doing something really crazy. And I think a lot of that has to do with writing the right code, sort of speaking the right code language, speaking the dialect of the language that you're using. So yeah, let's talk about the JavaScript array a little bit. So everything I'm going to be talking about is ES5. It has really good support. You should probably be using it. It's really cool. And if you need something, i.e. 8 or less, I'm so sorry for you. Man, that's too bad. But there is ES5 shim that will help you. So any underscore Lodash users, raise a hand. A few. So I use that too. There's actually a lot here in the JavaScript array that is duplicated in Lodash. Anyway, yeah, let's get started. So first of all, forEach. So these are all, by the way, methods on any array that you have in JavaScript. So forEach is a method that takes in an argument that's a function, and it'll call that function once for each element in the array. So not super complicated. I'm sure you guys are familiar with this whole thing. You know, for I equals 0, I less than length, I plus plus. We all know that, right? This particular function is just summing up all the stuff in the array. You're probably also familiar with the for invariant. Got a check has own property, fun stuff. So let's look at that same thing with forEach. Really pretty simple, same thing. It's just that we're calling forEach, we're passing it a function, and that function is getting passed the value for each element of the array. forEach takes 2 arguments, a callback function and an optional thisArg. The callback function will be called with the value, the index, and then the reference to the full array for each element in the array. If you pass in thisArg, then the callback function will be called with it as this. I personally prefer to actually bind it instead of relying on that, but it's another way to do it. So let's talk about some of the things that forEach is good at and some of the things it's bad at. So here's a simple function that just searches for a match that you pass in and returns the match. Notice how we've got return here, and then we've got return here. Now this isn't going to work. Can anybody know why? Exactly. Yeah, we're inside of this function right here, so that's where we're returning from. forEach will run for every element of the array. The only way to stop it is to throw, but that's that's kind of a bad practice unless something went wrong, right? So yeah, forEach is sort of an unstoppable monster until it finishes its thing. So if you need to return something or to interrupt the flow of going through everything, then that's not the right tool for the job. You do need to use a traditional for loop. So let's look at something that it's really good at. So first of all, this is the example with the for, and there's actually a pretty big error here. So this is a function it's returning an array of iterator objects, or iterator functions, I should say. And the whole idea is like with the resulting one, if you call element 0, then it's going to increment that that number on the original array and then return what was the original number. So my IntelliJ highlighted the little I here, and does anybody know why? You can just shout it out. Yeah, exactly, it is. So by the time we finish here, I is scoped to this function, make incrementing array. I is equal to array.length at the point where you're executing it. And there's ways to get around this and still use the traditional array, or sorry, a traditional for loop, like doing a function that it's sort of wrapped in. But you already have that with the forEach. So this is the same thing, but it's going to work because this time I is bound to this particular call of the function, which would be the right index. All right, let's talk about map. So when you call map, you're going to create a new array off of the array that you're calling it on. The indexes are all going to be the same, but the values are going to be different, and the values are going to be the result of calling the callback function. Let's look at some examples. So one thing I like to do, let's look at this parseInts function. Now you probably don't want to do this because you need to pass the radix in to parseInt as well as the string to be parsed. But it's just an example. So here it's basically like you might call this with an array of strings that need to be parsed into ints. So it's formatting it. And I actually, I use it for formatting an entire array a lot. So another thing for Lodash users, you probably know the function Pluck. So that's what this is basically doing. This is maybe taking in an array of users and it's returning an array of usernames. So since it's being returned from the inner function, it's going to end up with an array of just the usernames. Finally, let's look at make alternating colors. So this isn't even dependent on what the values of the array are. It's returning a completely new values, but it's based on the colors. Of course, there's better ways to do something like this in CSS, but you get the idea. So the arguments are pretty similar to forEach. We get the value, the index, and the full array with each iteration. And again, it's called on every element of the array. And then there's also the optional this arg. All right, so filter. Filter filters the array, believe it or not. So kind of the same thing. You're going to pass in a callback and the callback will be called once for every element. This time you're returning truthy or falsy. If it's falsy, then that item is not going to be included in the resulting array. So let's look at a few examples here. So the first example I use sometimes if I have an array that has like null values or falsy values. So this is really just like an identity function. It's returning the first argument passed to it. So if that's a falsy value, then that will not end up in that return value. Next, let's see. So get even values. It's just using the modulus operator on the index to just get the even values. I think my math is right there. Don't quote me on that. Not for production. And last, so now with this last one, we're passing in an array and sort of a search field. So this is just getting all the elements for the given state, for example. So like if I'm passing in maybe all the users and I only want the ones from New Jersey, then that's what it would give us. Arguments to filter, same exact thing as map. We got the value, the index, and then the full array. and an optional visarg. And now, let's see, how are we on time? Okay, cool. This is the complicated one, and it's also, I think, the coolest. So reduce is a way of taking an entire array and reducing it to one value. The value can be, it can be anything. It can be, number, string. It can be an object. It can be another array. But the idea is you're iterating over every element, and you're going to end up with one value. So let's actually look at the callback first, or at the arguments first this time, because it's a little bit different than the other ones. So you've got the previous value. The previous value is sort of what you have so far when you're building that single value that you're going to return. You've got the current value, so that's the current iteration. That's the one that you're on right now, and then the index, and so the index is going to be the one of the current value that you're on. And then, again, the full array. Then you have an optional argument of the initial value. I'm going to talk about that in a minute. It actually changes how reduce works. So let's look at just a few uses. So one of them, I'm just making the sum of an array of probably numbers, right? Or, it'll cast it. Anyway. And so really, all this function does is it takes previous value and current value, and it adds them up. And that's what it returns. It's going to do that for each element, and we'll end up with the sum of the whole array. So this next one, make existence lookup. This is actually something that I use when I know I'm going to have to do a ton of lookups into an array, and I don't want to use index of over and over again because it's an order n operation. It could get kind of expensive if we have to do it a bunch of times. So this returns an object where each element points to just the value true. And so here we can see that I'm actually starting it out with an initial value of just an empty object. Actually, I probably should have done object.create null here, but whichever. And so yeah, so previous here is going to be actually start out with an empty object, and since we return previous, again, it's going to be the previous value every single time, but with whatever the last value was added onto it. So let's kind of step through how reduce works. This helps me a lot. And actually, if you go to the Mozilla Developer Network, it does this sort of same exercise to show you. So hopefully it does a better job than I do, but we'll try. Again, this is the sum function that we looked at earlier. We're calling it with an array of 5, 10, and 20. So let's look at the first call. So for the first call, we're actually not at index 0, we're at index 1. So the reason that we started at index 1 is because there was no initial value passed in. So it calls it with the first two values. 5 starts out as the previous value, 10 is the current value, and then so we add it up, get 15. So we take that 15, and now that's going to be the previous value next time we call it. So we've got 15, and then current value is 20. That's the one that we're on, index 2. And then we get 35. Okay, so there's actually a problem with the sum function that I wrote, and I did it intentionally just to kind of show off the difference here. So first of all, so what do you guys think happens when you pass in an array with just one element? Any guesses? Just shout it out. Index out of bounds. Not a number. So here's what happens. The result of this is 5. Since there was no initial value and it only has one element, it just returns what the first element was. Kind of a weird edge case. Now, what about this, though? What happens now? Any guesses? So this is actually an error. It's going to throw an error. Calling reduce on an empty array throws an error if there's no initial value. So I don't know about you guys. I think it should probably do 0 in that case. Let's fix it. Great. So now we've got our initial value of 0. So that should work for the last case. Let's look at what it does this time, though. Let's step through again. So this time we've actually got that first call with index 0, since we have the initial value. So this 0 here, previous value, that's the initial value that we passed in. And then it goes through like you would expect. These are the exact same calls as before, actually. Any questions? Out of time?
Probably take a few questions if there are any. Going once, going twice. Oh, in the back.
Yeah.
For the stream, the question was, is there a way to do reduce in the opposite direction?
So there's a reduce right, and all that does is instead of incrementing from 0 to length, it does, or length minus 1, it does the other direction, length minus 1 to 0. Does that answer, is that what you're looking for? Okay, cool.
Any others?
Yeah.
Do you find yourself using or chaining them together, like saying a map to a filter to a reduce?
All the time. Yeah. Any other?
Oh, one more in the back. Okay, this will be the last one.
Sure.
Sure, that'll be the last one. So he's going to show us an example real quick.
So I actually put together like an exercise for you guys to do, and it's up on GitHub. I'll post the link later. Oh, is that me? Oh, it's the... Okay, so don't look at this because it's the answer, but you know, I guess look at it though. So, and I just kind of separated out where what my functions are. But yeah, that's kind of what what at least one thing looks like chained together. I probably should have come up with a better example. Oh well.
Awesome. Okay. Thanks, Jesse. Round of applause for Jesse. For those of you that may not have noticed, there was forks missing. If you wanted a salad, there are now forks in the back. If you were like waiting for a fork teacher, so you can go ahead and grab one of those. And then we'll just have Kent get set up here.
Is my microphone on? It sounds like it is. Okay. Having trouble getting this thing to... I'm clicking, but nothing's happening. So... Oh, it was Adobe dot... I'm just going to pull it up again. Okay. Feel free to tell a funny joke about LinkedIn and Microsoft to your neighbor. Okay, there we go.
Just real quick, with regards to Jesse's talk, you love map and reduce and filter, then throw some ES6 in there and do some fat arrow functions, and you'll be finding you're having a real good time.
There we go. How's that look on your thing? Look good? Okay. Hello, everyone. My name is Kent C Dodds, and I am here to talk with you about ASTs. Who knows what AST stands for? Right, awesome. AST stands for Abstract Syntax Tree. Who knows what AST stands for? Yeah! All right, so you've all learned something. Thank you very much. Just kidding. So I like to start out my talks with giving expectations, so this talk is not going to be a deep dive into parsing, tokenizing, and lexing. Like, I don't even really understand those concepts really well myself, but some people do. So I just totally forgot something. Whoops. Yeah, well. So yeah, we're not going to be talking about that. It's also not going to be everything that you need to know about ASTs. This is the beginner's guide to ASTs. And I should probably also say that, this is the beginner's guide to ASTs, but the concepts are not entirely beginner. And so if you have, if you struggle to understand what is the purpose of this is or what's going on, don't feel bad, because it's not especially if you're a novice programmer, this isn't like the entry-level stuff. But hopefully I can explain it in such a way that you can all understand. So yeah, we'll give a basic intro, and I'll give a little bit of a practical demo. It's actually mostly not practical, but it's fun anyway. And yeah, hopefully I'll get you a little psyched about ASTs. So this is code. You know that? Just kidding. Of course you know that. This is actually a module called Star Wars Names. You can get it on NPM. And it exposes two functions. All is not a function. It's just an array of Star Wars names, 100 Star Wars names, like Luke Skywalker. And then random, which allows you to get a random item from that array. And so we write code like this because we need to be able to communicate with each other about what the intent of our program is. But when the computer looks at this, it doesn't see this at all. What it sees is something more like this. This is called an AST, and this is a JSON representation of the abstract syntax tree. So you can't really see it too well. Don't worry, we're going to look closer at this later. But it's an object, and it has a body, which is an array, and it's this tree of other objects. So here we have a program. There's a variable declaration, and that's a variable declarator, and that has an identifier called unique random array. It's like crazy, and guess what? This isn't even our entire program. You see it's chopped off at the end. So the abstract syntax tree is really, really big. And it gives us a way to take our JavaScript program and represent it in a JSON object so that we can, and what this gives us is a lot of power to be able to manipulate this and then take that JSON object and put it back into code. And so let's just pretend for a second that you wanted to change all of your variable names to Star Wars characters, because that's obviously better, right? And so instead of having something like, a unique random array, we'd want Luke Skywalker or Obi-Wan or something for that variable name, because that's so much more clear. You could do this with an abstract syntax tree where you say, okay, computer, give me the JSON object that represents my program. Let me go find that variable, and I'll change what the variable name is, and then I'll spit that back out to code. And now suddenly my variable name has been changed. If you try to do the same thing just with a regex or something on your program, it's going to be a lot more difficult. And so this is part of the power of ASTs, is it allows us to manipulate our programs so that we can, so we don't have to deal with crazy regexes and stuff. The other side of it is it allows us to inspect our programs. And so we can say, we can have rules that say if you have an if statement that isn't followed by a curly brace block, then that's an anti-pattern. So you have if foo is true, blah, then console log blah. This would be potentially an anti-pattern, because you'd actually want to have that inside of this block with the curly braces, right? And then on new lines and stuff formatted nicely. And so you can do that with an abstract syntax tree. you can inspect the program, and if it's breaking any of your rules that you have defined, then it can say, hey, you should have a block around this. You can't just have an expression. So these are a couple of the things that we do, and if you're using Babel or ESLint, this is exactly what they're doing. Who in here is using Babel? Transpiler, awesome. Or TypeScript, anybody using TypeScript? Awesome. And anybody using CoffeeScript? I don't, yeah, never mind. So, sorry, I shouldn't jab at CoffeeScripts. Really smart people built that. So, yeah, or who here is using ESLint? Okay, awesome. Those of you who aren't, I hope you're using a type system, because if you're not, then you should be using ESLint. So take a look at that. But these tools are using this abstract syntax tree to manipulate our programs and warn us of potential errors in our programs. So we're going to take that JSON object and we're going to make it a graphical representation here. This is code for computers for humans. So we take this and like you can't see this. We're going to look at this a little bit closer. But you've got this program, and that has a couple of children nodes. So each item in our program is called a node. And so we have the program node, and that has these other nodes that are associated with it, like variable declarators, I think is what these are. And this builds out this tree of nodes where you have a root node that has children. Those each have their own children, and it branches out into this enormous thing. But this makes it a little bit easier for us to consume as we're exploring things here. So we're going to go ahead and do that now. So this tool, JavaScript Ast Visualizer, thank you Joint.js for building it. They're actually just demonstrating their really cool graph thing here, and they just use the AST for like who knows why. But we're going to use it for the AST features. So yeah, we have a really simple program here. We'll just bump that up so everybody can see. That is, yeah. So we're declaring a couple variables, and we have this add a function declaration, and then we declare another variable. And this has an expression where we're calling this function with the variable 2 and then b. So this can be represented as an abstract syntax tree, where we start out with a program that is like everything in the whole program, everything in the file, and that has a couple of children. The first child here is a variable declarator. That's the var a equals 42, right there. So this whole thing together is what's called a variable declarator. And don't get like too boggled down by all the different names of these different nodes. That's less important when you're like just learning the basic idea. Just realize that each one of these nodes is important and has a name, and you can go research those later. But yes, this is called a variable declarator, and a variable declarator node has a variable declaration node. And, or, sorry, I got that mixed up. Yeah, variable declaration node has a variable declarator, and then the variable declarator node has 2 children, an identifier, and a literal. These are actually not nodes in the same way that these other items are nodes. These are actually properties of the variable declarator node. And we'll see like specifically that in a little bit. So if we were to, and you have the same type of thing with this variable b, which is basically the same kind of idea here. So if we were to modify this program a little bit, if you weren't aware, you can actually do this. You have this variable a, so you have one var declaration, and then you can have multiple declarators on that var, that variable declaration. And so now if we look at what our AST looks like, we now have a single variable declaration for both of these variable declarators. And so what this means is this variable declaration has an array of variable declarators, and one of them being the variable a and the other being the variable b. So hopefully it's making sense that our programs can be represented by these ASTs, and like as we manipulate them, the nodes will obviously they just represent the piece of the code that they are like representing. That was said poorly, but that's basically the idea. I'm going to go ahead and give you all a chance to ask any questions before I move on. So I will not speak again until I get at least one question.
Yep.
All right.
Mike coming.
So have you found a need, or what have you found as a need where in something you've written, you've actually needed to modify an abstract syntax tree?
Yeah, that's a great question. So if we go to npm js.com, and here we look for Babel plugin, we're going to see a lot of Babel plugins. And if you're familiar with Babel and the concept of transpilers, their whole job is to take in code, make an abstract syntax tree with their parser, make some modifications, transform it, and then spit it back out to code. One of the most common use cases for that is transpiling from ES6 to ES5, so you can ship to the browsers of today with the code of tomorrow. But then there's actually a lot of other really cool things you can do when you have this plugin system, where I'm trying to think of a good example that isn't really confusing. One example would be if you're, I should close this, if you're a React developer. I'm at an Angular meetup, but how many people have played around with React? Okay, cool. So you know that if you're going to use JSX in your code, you have to import React because what that transpiles down to is react.createElement. Well, I don't like doing that because it's like annoying to have to do that if I don't actually need React in that code. And so I have a plugin that will detect, are you using JSX? If you are, I'll add that in for you. And so there are a ton of really cool things. Another awesome thing is how many people use code coverage for their code, for their tests, unit tests. If you don't, you probably should look into that because it's a good idea. But with using a Babel plugin, you can instrument that code for code coverage by just sticking in the right variables and making sure that you're tracking when different ternary operators or if statements or functions or lines are being called. And yeah, using an AST, that's extremely straightforward. The tool or the plugin that I've come to use is like 300 lines long, and the guy who wrote it was his first ever Babel plugin. Just to give you a little bit of context, the tool before Babel plugins were a thing was hundreds and hundreds, thousands maybe, of lines long, just of really complicated code to make this kind of thing work. So ASTs make these kinds of things really easy. Did that answer your question? It was probably a lot longer of an answer than you were looking for. But any other questions before I actually? So I'll just give you the next couple of minutes. What I'm going to do is we're going to actually write a Babel plugin, and then we're also going to write an ESLint rule. So any other questions before I do those things? Yeah.
So under the covers, would Atom or WebStorm be using this to be able to provide the underlines under things? Is that how they access that, is with ASTs? Yeah,
I'm fairly certain, having no actual knowledge of this, if they're not doing that, like what on earth are they doing? Because yeah, it's the best way.
So to get the AST part of it, do you partially compile? I mean, it looks like there's on this site you were on, there's some library that allows you to do that. But what's happening in the language? Like
yeah. So that was like what I said right here. No, it's good that you bring that up. So yeah, that's the parsing. Parsing, tokenizing, and lexing. So the parser goes in and like regex is like craziness that we don't have to do, thank heaven. And then it says, okay, this piece means this piece means that, and then it connects those into nodes. And there's a fantastic talk that I should link you to a little bit later about how that all works. It's really, really awesome talk. Great. I'm going to ask you to hold off on your questions until the end. Is that all right? Okay. If I don't or if we don't answer them, come talk to me after. Great. So that's the AST. This is so cool. This is the AST Explorer. If you go to astexplorer.net, then you get this really, really awesome app. Basically, it allows you to explore the syntax tree as JSON of your code in real time. And so here we have this tips, and that when I click on tips, it'll take me right to the variable declarator that it is. Specifically, I clicked on the word tips, and so that's the identifier for this variable declarator. And as we recall from our last little experience here, a variable declarator is one of an array of variable declarations inside of this variable declaration node. And so what's super, super cool about this tool, though, is it allows you to transform your code. And so here you can say, I'm using the Babylon 6 parser. So like, whatever, it's just a parser. Don't even worry about it. And that's the parser that Babel uses. And then I can say I want to transform this with Babel 6. And then I can write out my Babel plugin right here and see what the output would be. So the default here is it takes all identifiers and it reverses them. So print tips is now spit. So kind of fun stuff. Like I said, not entirely practical, but still fun nonetheless. I'm going to bump this up just a titch. So let me explain a little bit about how writing plugins for these kinds of systems works for many tools. This is called the visitor pattern. And so here in our program, we have all kinds of different node types. So we have this string literal node type, and we have this identifier node type, and that is part of a function declaration node type. So all of these are different node types. And if you want to manipulate your abstract syntax tree, sure, you could take that huge JSON object and navigate through it and try to find the things that you're looking for. But instead, what Babel allows you to do is you say, I'm only interested in identifiers because my whole job is to reverse all identifiers in this program. And so I only want identifiers. And when you come across an identifier, then I want you to give me the path, and I'm going to make a change to the path. In this case, I'm going to reverse the name. And so this is a really powerful kind of API that allows us to really easily make modifications to the abstract syntax tree, and without having to traverse this into the AST ourselves. And then once we've made our modifications, we just hand that back to Babel, and it'll spit out the code for us. And that's what we see here on this right side. So any quick questions about that? Good question. Is the visitor pattern specific to Babel? Is this code that we're seeing specific to the Babel plugin? So yes, this is the Babel API. ESLint API is similar. They skip out on this visitor object, the greater object, and their API is actually just the visitor object itself. So yeah, but the pattern is definitely a common pattern. Great. So what we're going to do is how much time do I have actually? Like an hour?
Probably not an hour.
Just kidding.
Let's say 10, 15 minutes.
10, 15 minutes. Okay, totally got time. So this is the start of our Babel plugin. So we have this program. We saw it before. It is this get random Star Wars names. And yeah, we're going to manipulate this so that we can turn every variable name into a Star Wars character, because this is really practical and you'd want to do this all the time. So that's what we're going to be doing. I've already set up some stuff in here that's not really relevant to our conversation. Here's our list of Star Wars name people, and I'm lowercasing it, making it ready to be an actual variable name. So instead of I don't know, R2D2, it's R2 minus the hyphen thing. So anyway, this is stuff that you don't need to concern yourself with. We're basically, all that we really are going to care about is this get random Star Wars names function that we're going to call to get our random Star Wars name. So we also have our plugin set up. We export default, our function, and inside here we accept this type, or we accept this object. We're destructuring it, yeah. We're assigning the types property of that object to the variable t. So this is really common. Many Babel plugins have the same kind of structure. And then inside here is where the meat of the plugin will reside. And I'm going to cheat really quick because I totally forgot to do this. Sorry, one second. Jokes about LinkedIn and Microsoft. Okay. So, yeah. So basically, what we want to do is let's actually we'll explore this a little bit further. So if we're going to be renaming all of these variable names, then what we want to have access to is the node that these variable names represent. And in our case, that's an identifier. In every instance, we also want to rename this all and this random, and we'll rename the random function. All of these are identifiers. And so that is the node that we're going to be visiting, is an identifier. And so we'll simply say identifier here, and that will be a function. And that's going to take a path. So, yeah, let's see. Okay, so then we're going to get a random Star Wars name for our variable name for the new name. So it's going to be const new name will be get random Star Wars name. So we don't care how all that black magic works, but now we know that we have a new name, and I can actually console.log right here to see what that new name is. Yeah, and we've got like a bunch of these, right? One for every identifier in our program. So far so good. The next thing that we need to do is get the the API for this thing is really not it's not entirely obvious, and it's something that you can go look up in your own time. So I'm just going to tell you to rename a variable name. All you do is you take the path, and you want the scope of that variable or of that node. So like I have this get random item here. I'm referencing it right here. So I want to be able to rename both of these to be the same. So I'm going to take the scope of this variable here, and everywhere inside of that scope, I'm going to rename all instances of this to my new Star Wars name. So we're going to take the scope off of the path, and we'll rename the original name, so whatever the original name was, which is path.node.name. So now we're mucking around with the node. In our case, that's an identifier, and that has a name property here. So we'll rename instances of that variable to the new name, the Star Wars name. And now we see that we have all of those variables changed. So that's pretty cool and stuff. We have, oh, and actually, since the last time I made this, like last time I did this, it also changed these, or module. It's not and require, but it looks like it's protecting me from doing that now, which is great. So yeah, but it's renaming these variables, and now that function that used to be really boring and random, it's now called Han Solo, which makes it so much cooler. And Mace Windu is now our get random item. So that's kind of cool and stuff. So hopefully, like I said, totally impractical. I hope you don't do this. But what's cool about this is that you have all of the power in your hands to do whatever it is that you like to your program. And so if there's a lot of weird boilerplate that you have to do in your program, like you could AST that away. And I just think that's super cool. Another thing that I didn't actually describe for this is there's this other concept called a code mod. Who here has heard of a code mod before? Okay, one person. Great. So a code mod is basically a one-time transformation of your code. And so this is really great for when if Angular 1.6 comes along and breaks an API or two, if you could program or if you could write a transform that could take your old code and convert it to the new code, to that new API, then you could run your entire code base through this code mod, and poof, what you get out is like the upgraded code. And if you have 150,000 lines of Angular code, like you're going to be the coolest person at your company for doing that. So like that's one application that's really cool. And the React team actually, when they push a breaking change to React, they will provide a code mod as well. So people normally are really it's really easy to upgrade even with breaking changes. So yeah, transforms of ASTs, super awesome. And yeah, I recommend that you check that out. With the 7.5 minutes I have left or so, I'm going to actually, so the last thing that I'm going to do is write the ESLint plugin, but I'm going to go ahead and stop and ask for questions now. Yes. Yeah, so the question was, would this be useful for obfuscating your code? I can't say that word, but uglifying your code, minifying your code. Absolutely. I'm pretty sure there is an uglifier. That's a Babel plugin. Uglify.js has been around for a really long time, and so that's the one that I still use. It's fantastic, but yeah, Uglify.js would be like a really good one. In fact, let me see if I can find it. As a joke, who here knows who Sebastian McKenzie is? Okay, Sebastian McKenzie is the guy who created Babel. He initially created it to learn JavaScript. What? So, yeah. So let me see if I can find this. Babel plugin emojification. So I kid you not, this Babel plugin will take all of your variable names and turn them into emoji. Yeah, like I wish that he had a screenshot here, but he has a talk that he created this for his talk just to show the power of this thing. Let's see if the GitHub is any different. Yeah, it's not. Bummer. Maybe if we jump into the source for a second, we'll see all of the emoji. Yeah, there they are. So it's basically like the plugin we just wrote, just a little bit cooler because it's emoji. I mean, I didn't just say that emoji is cooler than Star Wars, but so but yeah, like this kind of thing, like it's fun and it's dumb and it's cool. But yeah, you could totally do something like minification with a Babel plugin. Any other questions? Okay, great. We're gonna write an ESLint rule now. Oh, whoops. Oh, I forgot to make a before and after on this one. Whoops. No looky. Let me get rid of all this. Okay. So, like I said, with ESLint, the API is slightly different. Instead of having a visitor object here like we had before, it's actually this object that you return is the visitor. And then here we have some code that is, here we have some code that has two if statements. One of them is awesome. The other one is not, because it doesn't have a block. And so FYI, this is totally legit JavaScript, but if you decided that you wanted to have another thing that happens if something is greater than 3, nope. That will happen every time, no matter whether something is greater than 3. So this is why it's good to have a block, so that you can make sure you know what code is going to be run when something is greater than 3 in this scenario. But in this case, we were inexperienced or just learning, whatever, and we just put it on a single line, thinking that we're super cool, and we want to lint against this. And so what we're going to do is write our ESLint plugin to fire an error when there's when you don't have a block for your if statements. So let's think about this again. We'll explore the AST a little bit, and here we have our identifier there. That's the something. We have this binary expression, which is kind of cool. That has that identifier inside of it. And if we go up another level, we have this if statement. And similarly, we have an if statement for this one. So that's the common thing. We have a good example, bad example. This is the common thing that we're going to be linting against. And so that's the thing we're going to want to visit in our visitor. So we'll say if statement with a capital I. And that will also be a function. And in ESLint, and again, like ASTs are a common concept across these tools, but the APIs to manipulate or traverse these ASTs is a little bit different. So with Babel, it was the path. With ESLint, what you get is the actual node itself. And so here, all that we really want to do, here, we'll go ahead and console.log our node. And here we see we have our nodes. The type is if statement, and this one has consequent, and that consequent is the expression statement. So that's like it's the consequent. It's like if this statement is true, then this is the code that will be run. There is no alternate. If there was an else, that would be the alternate. And so we also have this other node that's our second if statement here, and it has a consequent node, and that one is a block statement. So our consequent of our first one is just an expression statement. Consequent of the good one is the block statement. So we basically just want to see, is the consequent a block statement? If it's not, then that means that they're breaking our rules, and we're going to warn them of that. So I'm going to create this function right here. Function is block, and that's going to take a node. And let me totally forgot where I was. Here, I'll just look it up on this little doodad. Yeah, so we'll say if that node, we'll just start out with this. If that node.type is equal to a block statement, then we're good to go. So we'll say if the node.consequent, so remember that was the node that we want to check, that the consequent is a block statement, and we'll wrap that with is block. So if that node is a block statement, then we'll just simply return, and otherwise we'll just report this in a second. But I'm going to console.log the node just to make sure that we're only getting one node, and it's the one that we want. It looks like a return. Oh. I was like, there is a return statement, guys. I don't know. Thank you. There we go. One node. Okay, so we do have the node that let's make sure. So the consequent node is an expression statement. So we're filtering out the node that is good. And so now we can mess around with the node that is bad node. And with ESLint, the API for logging or for saying, hey, this is a problem, is using context.report. And this takes a configuration object where we provide the node and the message, yo, why you no block. And there we go. That's actually all that we need initially, and then we'll get this nice pretty output from ESLint saying where the problem was, what the code looks like, and giving our sweet message. Another cool thing that we can do is we can also provide a fix function. And what this basically does is it accepts a fixer, which is some special object that you can do stuff with and manipulate nodes and stuff. And so we could actually fix the code for them. We could say, okay, take that node and turn it into a block statement. And so then if people run later on somewhere totally separate, if people were to run on the command line ESLint foo.js -- fix, then it would actually run our fix function and transform it. So it would be basically a code mod. I use this all the time to remove semicolons from my code because who needs those? I'm serious. I don't use semicolons. So I'm a weird one. Yeah, so that's basically the idea. So if we wanted to make this a little bit better, then we could also do this. If I put else console log something else, it's take that, I can do no blocks and whatever. Then we could take a look at this else statement and see that this is the alternate and it's an expression statement. And so we could say is block node.alternate. If they're both block, then we can get out of there. And in this case, we need to say if there is not a node, or there's a node if there's not a node. Okay, I'm totally lost. I'm confusing myself. Yeah, there we go. Okay, so yeah, so now we can say we're checking both the if statement and the else statement and getting warnings for when those are not block statements. So yeah, I think that's pretty much it as far as that goes. So let me just give a couple of resources, and then we'll have a second for questions. So yeah, these are all of my slides are available. I have a link on the last slide here, and you can see these resources. This Babel plugin handbook is super good if you're interested in writing Babel plugins. And I also have the code mod. I recommend you check out this code mod talk because it's super awesome. Talks about like why code mods are so valuable. Like Facebook uses code mods a ton, and they have millions of lines of code, and they can upgrade them all at the same time. It's just totally amazing. So check those out, and please give me feedback right here. I am giving this talk next week, so this is a practice run. Thank you. So I'm going to Kansas City to give this talk, and I'd love to get your feedback on it. And with that, I will say thank you. Do I have a second for questions?
Yeah. Any questions for Kent? I know we already got a bunch during the presentation. Any that are left over? No? Okay. All right. Thanks, Kent.
Thank you.
I don't know. I don't need to walk on the stage. Who cares? All right. So anyway, thanks, Kent, for speaking to us. Thanks, Jesse. Huge round of applause one more time for them. Thanks again to our sponsors, Workfront and Adobe. We're grateful for them. And if there's nothing else, then we'll see you next month.